Hey, welcome to today's video where we're going to take another look at this Valhalla Power Analyzer. We fixed it in the last video we did on it a few months ago, maybe more than a few months ago. But yeah, we did a video not that long ago repairing this, and it's kind of sat in the corner for a while. It was way out of calibration. So today we're going to try to get it kind of roughly calibrated. We're not using NIST traceable calibration standards. We are using a relatively accurate DMM to calibrate towards. So yeah, we're going to calibrate this to the best of our ability here. We're going to follow the manual. The nice thing about these older instruments like this is they publish manuals on how to calibrate them and how to repair them, and they even have schematics available for it. So we're just going to follow the manual, go through it real quick, get this thing back in cal. That way, for anyone that's kind of thinking about repairing their own test equipment, you know, getting their lab set up with repaired test equipment, you get an idea how this process goes. You know, you can follow along in the old video, which I should have down in the description, on how we fix this thing, and then we can follow along on how to get it where it gives you at least a halfway decent measurement. Because like I said, this thing's way off right now, so we're going to get it as close as we can. We'll be using our Keysight to calibrate it, so it's a pretty accurate measurement that we get off of this. It has been 2 years since this was calibrated, and I also repaired it. So definitely, you know, this guy's out of cal, so it's not a valid calibration, but it's good enough for what we do here in the lab. Okay, well, let's get this thing set up and just jump right into it. I don't want to drag this out any longer. Before I adjust the display here, I just want to show you what I'm doing. We have R8, R45 and R49 that we're going to adjust. So you'll just see me kind of twisting the knob out of frame while you're looking at the display there. So yeah, these are the potentiometers that we're adjusting for the voltage range, and then we will do the current. That's about as close as you're going to get to exactly on 10 volts. So R8 is our adjustment here. Okay, now we need to adjust the 150 volt range, and that is R45, which looks like it's very close. I don't think we're going to beat that. So now we will change into 300 volt range. Should still have about the same accuracy there. But in the 300 volt range, we will go up to 300 volts and check the 300 volt range, and that one adjusts on R49. All right, R49 will have a very small adjustment too. Okay, so now the voltage range is adjusted, and then we just verify it with AC now. So the adjustments are all done in DC, verification is done in AC. For doing the current range, we're not going to be able to do all of it because 10 amps is as high as I can go on here. But yeah, we're at 100 milliamps in the 200 milliamp range. And we're right on, okay, the 100 milliamp range is good. Let's go ahead and take it up to 2 amps range and check it. So we take that there and then bring it up to 1 amp, and that is right on as well. So it looks like our current telemetry is good. I'm not going to be able to do the 20 amp range, at least not all the way. We can bring it up probably about, we're also limited to 5 amps on my power source because I'm using the 30 volt O1 right now. So we'll go ahead and put it in the 20 amp range and then take it up to 5 amps and see what we get. So that seems close enough. So I think I'm just going to leave the current calibration the way it is. I'm not going to touch that one. Okay, the last adjustment is this watts display here. And so what you do is you first have no voltage on the input in the 300 volt range, and then load the load side of it just to make sure that there's nothing, and then make sure this display is 0, 0, and we need to adjust R29 for that. All right, so the lower range was good, but this upper range is not, so let's go ahead and adjust it. This one is going to be R28 this time, and we just want this to read 0. Yep, and I think that's as close to 0 as I'm going to get it. All right, so let's validate that this actually works now. What we have going on here is two 2K power resistors in parallel, so it's a 1K resistor right here, and this is hooked up in parallel to the AC input there, so we can see our volts in. We are on amps, and then we have our watts here. So let's go ahead and turn on our variac. We'll just start all the way down at the bottom and slowly bring it up to 115 volts. Obviously, you need to be careful with something like this. You can easily hurt yourself on mains 115. So there we go. We are right on 115 volts. These two are matching very closely here. So very close match on the AC voltage, right at 117 milliamps. So, you know, some variation probably in this load that I've made. And then we are right at 13 watts, which is exactly what you would expect for a 1K resistor. It's 13.3, and this is reading the 117 milliamps, so that wattage is just a hair higher than what 1K would calculate to, so probably just the load that I built. Went ahead and cut that power off. Yes, this is definitely working. Plenty accurate for what we were doing. And again, we're not going for like a NIST traceable calibration here. We just need to get it back to being accurate, because after the repair from when it was dead, we were off by a little bit. We were probably off by 2 volts. Our watts were probably off by like 12. So yeah, we brought it back in to where it needed to be. And it was a pretty easy process. I mean, this old equipment's great because the manuals are written in a way that you can service them yourself, unlike newer equipment where it just says send it back to the factory for repair. So yeah, it's a nice kind of classic piece of equipment, pretty easy to get back in cal. No real repair here, just getting it, you know, back to where it's reading something stable. Just to show how that hookup was in the back. Your 115, your line power's coming in here, and then it's going down in parallel into this other instrument, so we can get a second measurement there, and then we have our load coming across there. And so yeah, that's just two 2K ohm light resistors here that put a piece of bus wire in between, and then just tacked on some banana connections there. So yeah, easy enough for testing this to validate that it's working. So now it's probably time for me to sell this thing. The main reason why I'm probably going to sell this is because I do have this Zetron. So whenever I need a power analyzer, I would just use this. Yes, it's a 3-phase, but you can use it in single phase, and it gives you a lot more measurements than you can do with this guy. So also I can hook this up to a computer. So yeah, this is my go-to power analyzer when I need one. It's a little overkill for what I do here. And same with something like this is great too, because you can take a look at the power factor, and the power factor really will tell you a lot about the health of your AC to DC converter when you're dealing with those. So, you know, something like this is great because it takes the place of a couple of instruments. But if you really are getting serious about AC power electronics, something like this is really what you need, because you can get that power factor as well. Okay, well, that really wasn't too painful. We got this thing calibrated, giving us very believable numbers on our voltage, our current, and our watts. So yeah, with that 1K resistor, 115 volts in and 13 watts out, you know, that's about right. So I'm happy with the way this came out. It really wasn't that rough. It's really nice that Valhalla had the manual still hosted to this day on their website. You know, I didn't have to go find it somewhere random. It was still on their official website with the schematics for, this is a really old piece of equipment. So kudos to them for still hosting it. And I wish modern companies would still do that. You know, for example, this Keysight here, they have problems. The main control board here that drives it dies, and then you have to buy a replacement. They're like $400 for the replacement board. And they don't even want to sell them to you as a consumer. You know, it has to be a business that buys it. They won't even quote it if you say that you're a consumer. So you have to like check a little box saying that I'm a company and I'm a professional, you know, to even buy the parts to fix it. It's just ridiculous. And then they don't really have very good guides. Pretty much all of their repair guides end in, okay, now you have to contact us to get a quote on how to get it repaired, you know. So it's kind of obnoxious. New equipment like this doesn't really have repair guides anymore. I mean, sure, the calibration procedures are out there, but they don't even want to give those out to like non-businesses half the time. So yeah, it's rough in the test equipment world these days. It really would be nice if we had some right to repair on it. I used to talk about that more on the channel. I've kind of gotten away from talking about right to repair on the channel, just trying to keep politics off the channel. But yeah, you know, I'm happy with the way this repair went. It'd be nice to see some modern equipment that was this easy. And yeah, this one was more of a calibration. But yeah, I hope you guys liked the video, and I'll see you in the next one.